Now, graphing is a good way to approximate, solutions of systems of nonlinear equations when the coordinates of the intersections are not integers. Um, However, there are times when we do need to get the exact answer. And this is where substitution and elimination methods come in. So I'm going to take a look at this example. Before we start solving it, let's go back to our decimals and see what answers we're expecting to get. So, okay, so these are the two equations that we are going to solve by using substitution method. And by looking at the graphs, we see that they have two possible solutions. And those solutions are x is -4 and y is 11. And the other one is, the other intersection point is 1, 1. So how are we going to get those? By substitution method. Well, it's good to note that both of the equations are already solved for y. So in other words, y is already isolated in both of them. In fact, the left-hand sides are both y, so the left-hand sides are equal. So what do you know about, or what conclusion can you make about the right-hand sides if the left-hand sides are equal? Well, if the quantities in the left are equal, then we can also make the quantities on the right equal to each other. So in other words, we can replace y by whatever it is equal to in the other equation. So go ahead and copy the right-hand sides and make them equal to each other. Okay, so this is now, an equation using one variable only. So if we arrange that in standard form, we get x squared plus x. You have to move the 2x over, so that's going to become plus 2x minus 1. Then move the 3 over also. I'm going to get -3 is equal to 0. So simplifying further, we get x squared plus 3x minus 4 is equal to 0. And then at this point, you would say, oh, how am I going to solve this? So if you recall all the methods for solving equations, if you're not really sure about how to proceed, I would say, use the quadratic formula because it works for all. However, we mentioned that one of the disadvantages of the quadratic formula is it's time consuming. It takes a lot of steps. Now by inspection, you can come up with, the factored form of the left-hand side because you can find two integers such that their product is -4 and their sum or difference is +3. So we can have here, let's say 4 and -1, right? When you multiply 4 and -1, you get -4, but when you get the difference, it's 3. So that means this is actually factorable into x plus 4, x minus 1 equal to 0. Now, if you're lost, I don't know, like, you remember our x method, right? You put a -4 at the bottom, the positive 2 right here, or, this could also be interchanged, but get the idea, this should be the product, and 3 must be the sum or difference, depending on their sign. So that means if I go 4 times -1, I get -4 as a product, but when I subtract them, 4 to 31, I get +3. So then I can write the factors as x plus 4, and then x minus 1. Okay, so by using the zero product property, then we know that from the first factor, the solution will be x is equal to -4, and from the second factor, the solution is x is equal to 1. right? Which is actually the same results as when we were graphing. So we got -4 here, and then +1. So if you want to get the corresponding y coordinates, then all you need to do is plug these values in into either of these two equations. So this is one example of solving by substitution.